Now we have Robert. So he is now the VP of Engineering of Great Job. His topic is a bit interesting. It's called If We Know What API Are, Why Can't We Count Them? Let's hear more about his story.
I'm so excited to be here with you today at API Days Hong Kong. This presentation asks and answers the question, if we know what APIs are, why can't we agree how to count them? As we'll see, this question is very relevant to API security and API discovery, which are both very important topics right now. I am Rob Dickinson, VP of Engineering at Graylog. There's a picture of me with shorter hair. You can reach me after this talk. I'm easy to find. You can email me or you can follow me on GitHub or Twitter. So this question about how we count APIs, does it really matter how we count APIs, or is this a purely theoretical exercise? I would argue that it's a very important topic. API security really starts with discovering your attack surface. You have to understand what you have in order to understand whether it's secure or not. It's a pretty basic concept, right? What makes that difficult is that these APIs are fundamentally dark and they're constantly changing. They're not like websites or older technologies like that where we could just go and see what they're doing. We're going to have to discover these things, and we know that they're changing all the time. What our organizations really need is metrics that quantify the current level of risk and allow us to detect and alert on changes in risk. That's really fundamental to API security and this idea of understanding your attack surface, is being able to translate that into actionable metrics. But of course, we can't have metrics without agreeing what to count. So this is where this idea of how we count these things, what is it that we're counting, that's why this is so important, because what we count and what we choose to count is ultimately going to inform the kind of metrics that we have. That's ultimately going to inform the kinds of alerting and monitoring that we can do about those APIs. What we want to do is we want to be able to get to a place where we can make a statement like this. We can say with confidence that we know how many APIs we have, we know how many of them are new, and we know how many of them need immediate attention. So given this statement, how do we solve for X, Y, and Z? If we can do that, we're going to be pretty well off in terms of driving an organizational response to changes in risk. But again, all of this hinges on the idea of deciding what it is that we're actually going to count. And this gets tough. Seems easy, but let's take a specific example. Let's run an experiment. So let's pretend that we have a fictional cryptocurrency trading application here called coinbroker.io, which by no means is a real application. It's totally fake. Let's pretend that that site exists and that we're monitoring that API traffic. So the first thing we might see is a user registration. The second thing that we might see is a quote being generated. So this user has asked for a quote to buy 6 Bitcoin. And then another request where the customer is placing an order and they're saying, let's do that for the quote that I just had. So again, fictional application, very simple, just a couple things in play here. We took this very simple example and we asked a whole bunch of folks, how many APIs do you think are present here? And the answer kind of shocked us a little bit. So a whole bunch of people, roughly about half the people that we asked, looked at this and squinted at it and read it real close and said, yeah, it's one API. There's this thing called Coinbroker, and that's the API that they have. The same way that I would think about the Google Maps API or the GitHub API. Yeah, it's one domain name. Sounds like one API. That was about half the people that we asked. The other half said, oh, with confidence, there's 3 APIs here because there's 3 paths. There's 3 operations. So the answer must be 3. And again, this was about half the folks we asked. And even when we went back and we told those folks, hey, like about half the people voted the other way, a lot of those folks were pretty adamant that their original answer was the correct answer. And that really made us stop and think and was bordering on being a little bit frustrating because we're just trying to answer a simple question here. How many APIs are actually present? What do we mean when we say API in this context? Both of those answers are actually pretty logical. That's very frustrating. Now imagine that we're talking about GitHub or an actual real API, the Google Maps API. Well, there's hundreds, if not thousands, of paths that would be available in that case. So is that now the answer of one and thousands? I mean, how could it be either one or thousands? That's starting to get crazy, right? But you see where this is going. How many APIs are actually there? When we started asking people without showing that example, what are the reasonable ways that you would think of to count your APIs? There's a whole bunch of reasonable ways to do this. We've already talked about two. You could count the domain names, or you could count the unique routes. But that's far from the only way of answering this question. There's lots of other ways that are perfectly reasonable. Some folks said, well, we should count the number of gateways. We should count the number of IPs. We should count the number of hosts and containers. Count the number of physical and virtual servers, the things that actually have IPs where those APIs are running. Let's count those. That's reasonable, right? Other folks that we asked, when you think about counting your APIs, their answer was in terms of integrations. Well, we do this vendor and we use that supplier and we have this that we set up for this customer and that we set up for this customer. Some of those integrations were internal, some of those were external, but that was the way those folks answered the question. Other folks would say something like, well, I want to understand which of my APIs are approved by the security team, which of them are rogue APIs that the development team introduced and hasn't told anyone about, which ones are deprecated, which ones are zombie that were supposed to be phased out. That's also a very reasonable way to count APIs. Folks from a security background would say, I want to count APIs and group them by their user activity or their level of threat. How many of those users are valid? How many look like attackers? So looking at the consumption of the API, the opposite end of the spectrum from thinking about the infrastructure of the API, right? That's a huge range to think about. When we looked at all these different ways, and also what the industry has been doing around API design and API orchestration, we kept coming back to this idea that open API has already taken root in a lot of these places. It's not super popular yet for API security and API discovery, but that's also another way to think about counting the things that you have. Let's take that open API spec or GraphQL spec, but let's take that spec, let's attach it to the domain, and then we can count elements within that. And that spec basically gives us a way to agree on what's being described, and then we can attach our metrics to those descriptions and basically let those folks do the defining work for us. All of these, again, are perfectly reasonable ways to think about counting your APIs. And if you're thinking about API discovery, you'll see almost all of these ideas have been implemented by different kinds of API discovery tools, and some of those being, having more of an emphasis on API security. So let's take a couple of these and drill down, and let's talk about, as I said, all these are valid, but a lot of these have different trade-offs and different challenges that are involved. So let's go to that level of detail so we can see how we end up at the conclusion that we're reaching here. If you go on Google or you go on a search engine, you search for API discovery, a lot of what you're going to see is infrastructure oriented, APM oriented, in terms of understanding what are the hosts and what are the containers that are out there. That's a perfectly reasonable way to think about counting the things that you have. But there's two things that jump right out from this. A lot of the infrastructure that we're talking about, it's elastic, it's ephemeral. It's things that run in the cloud and then they get recycled off, they get replaced, they get auto scaled, all those things, right? Um, Counting infrastructure is much more difficult than it used to be in the days of having essentially static services running on your network. If you're looking at this from an infrastructure perspective, you're also missing all of the risk factors. Everything about the application itself and the application behavior, the user risk factors that go with that, you're not going to get any sense of that by looking at the infrastructure. Looking at the infrastructure may be helpful for other kinds of things around system monitoring, but it's really not that useful when it comes to API discovery in the end. Going back to our example that we started with, where we're recording the network traffic, we could look into that network traffic and we could identify the fully qualified domain names. That was the technique that got us to answer the number of APIs was 1, remember? The problem with that, or the challenge with that, is that ends up being very coarse-grained. Those domains probably aren't changing super fast, right? And they're also very large. It scoops up a whole lot of network traffic into those relatively large buckets. If we go the other end of the spectrum and we say that we're going to count all the unique routes on the system, I strongly believe that ends up being too fine-grained. It also ends up being overwhelmingly technical. Nobody in the organization is going to know for all the thousands of method and path combinations what all of those are supposed to do and be actioning at that level, right? Somebody knows, but one person is not going to know them all. That is too much to ask for. It's too fine-grained. You see this in discovery products and security products that use this definition of API, the unique route definition of API. One of the things that you see as a side effect of that is a lot of those products, they have to introduce this other concept, which is API groups or API categories or API families, to try to get that back to a manageable number. They might call them API services. There's so many variations on this. But recognizing that this is too fine-grained and wanting to get back to a grouping that feels more actionable to the organization, because it's difficult to manage thousands and thousands of these things. I would argue it's also pretty much impossible to do this kind of discovery without doing network monitoring. You really need to have a significant volume of actual traffic to be able to go and discover all those method and path combinations if that's what you're out to actually accomplish. What's fun about thinking about the spec approach is that the spec approach we feel like is the Goldilocks. It's just about right. It's not as coarse-grained as just looking at the domain name, but it's also not overwhelmingly fine-grained. If we can take that fully qualified domain name and attach a spec, then we can count the elements within that spec. That really feels like the best of both worlds here without it being overwhelmingly technical. This is also very open API friendly, which has a great community behind it. So that's a good thing. The main downside, though, is that idea that you're going to have to request or generate the specs. That doesn't just come from the network monitoring, although you really have to do the network monitoring too as a part of this. What's probably the biggest challenge that goes with this, though, is that while OpenAPI is very accepted in terms of API design and API testing and API documentation, it's not necessarily the most popular thing so far for dealing with security around APIs. But we argue that OpenAPI has a lot to offer in this regard. So it is a challenge that OpenAPI may be new to your security folks. And they may at first look at that as being a developer side artifact. And that's okay. But once we apply this idea to API discovery and the API security posture that comes with that, then this is really feel like it's starting to add up to something pretty cool. So what does that look like? So as I just said, we really feel like OpenAPI gives the richest definition for REST APIs. We can start with those fully qualified domain names. That's a good place to start because that's going to be what anchors those specs the way that we've talked about. So it gives us the right structure. This is also really convenient because of all the things that you could go to the security team or go to the organization and ask them and get answers with confidence. It's probably going to be about the domain names. What are the domains and the subdomains where those APIs are supposed to be running, where they're supposed to be supported? That is typically a relatively short list that you can ask for somebody in the organization to give you, and that is typically known. They won't know all the details about each path and operation and method combination and all that stuff. You can't ask for that up front. No one is gonna know that, but they will know the fully qualified domain names. So start with that. Then we want to attach those OpenAPI specs to those fully qualified domain names. Then we can count the elements within those specs. And this is really giving us the same kind of ontology now that we can apply across all of our APIs to represent those metrics about all of our APIs in a consistent way. We can then pivot those counts to include those factors around user activity and risk and quality, but think of those as buckets that are attached now to the spec, attached to the fully qualified domain name. This is where I think using OpenAPI for security posture management really starts to take on some interesting qualities. So now already we're talking about a development time artifact, the OpenAPI spec, but now we're going to be attaching these runtime metrics and the pivots around those metrics back to the spec and relating that to the spec. That's pretty cool. The other thing this does, though, is this also ties those metrics, at least in our experience, ties those metrics back to the organization or the team that actually owns that spec, who owns the API, right? Conway's law says that the services that we build and the APIs that we build reflect the divisions in the teams that built them. So by tying that runtime posture back to the spec, we're also tying that runtime posture back to the development team that owns that, as much as providing that data to the security and ops teams that are running that system in production. Now we're really on an interesting path to create actionable metrics that give a specific signal to one stakeholder within the organization to take action. And we're not asking that to be done in terms of having the organization describe that or describe the policies. We can simply attach those metrics by attaching them to the spec and then using Conway's law to do the heavy lifting for us. That's pretty cool. Now, you may want to jump up and stop me at this point and say, that all sounds great, but I'm not sure that I can count on my developers to give me these OpenAPI specs, and I'm not sure that I want to go and hound them for that if they're not already generating those. That is a legitimate concern. So the best way to address that issue is to generate those OpenAPI specs. If you don't already have them, generate those specs from the network monitoring that you're doing, from the call monitoring that you're doing. That is a transform that can be done on top of that network traffic. And that basically gives you an operational spec, even if you can't get one from the development team. That's pretty neat. The other thing that you can do if you really go down this road is you can ask your development team to implement spec introspection. This idea originally came from GraphQL. I'm sure they weren't the first people to invent that concept, but really popularized with GraphQL And it's the idea that you can go to a GraphQL API and you can ask it for its current schema. That's a really powerful idea to implement here. So in terms of thinking about your requirements for your APIs, if you can have an introspection route on top of that that returns the current open API spec, now that's a way to have APIs that are essentially self-describing, which means that they're inherently set up for discovery. And that's a pretty wild idea that we're seeing more and more people start to adopt. You can basically take everything that I just said and rinse and repeat for GraphQL. If you're doing GraphQL as well, that tends to be fairly coarse-grained at the top. That aligns well, usually with having a specific subdomain to that. You're attaching your GraphQL schema, which is essentially the spec. And then within that, you can count operations. It follows very much into the same kind of structure for those metrics, so that you don't have to have one way of thinking about this for REST and a completely different way of thinking about this for GraphQL, which unfortunately is something that you see sometimes in tools that aren't super savvy for GraphQL. Now we can go back to that original problem with all these ideas in hand, and we can answer this question now definitively. And we can say, in this case, based on the Open API spec, the most likely way of fabricating that spec is that you would say that there's one API and there's 3 paths. And that feels pretty good. Now, you could argue there's no reason why I couldn't generate 3 Open API specs, one for each one of these that has one path in it. And yes, that's technically possible. You could do it that way. But that wouldn't be the natural way to do it. The natural way to do this would be to have one coin broker spec that covers all those operations. Of course, your case may vary, but that just seems like the more natural approach. And also, if you go down that approach, you're more likely to have the Open API spec that you generate from your network monitoring to be similar to the one, or hopefully the same one, that your development team is using or that you're using for design, documentation, or testing. API discovery is just one of the capabilities that we're exploring with Graylog API security. We're providing the full security context for all of your requests and responses from your APIs. And most importantly, we're doing all of that with a self-managed database where all of that data remains under your first-party control. If you're curious about any aspect of what we talked about here today, API discovery, API monitoring, API alerting, please reach out. We'd love to share more about how we're helping our customers tackle these critical issues. Thank you for coming to my talk, and thank you for API Days for sponsoring. Always love to come here and really enjoy the programs here at API Days. Hope to see you back here in the future. Thanks so much.
Thank you, Robert, for his interesting sharing.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.